Welcome back to my channel. Yeah, y'all thought I wasn't gonna continue this little YouTube charade. Well, I'm gonna keep trying it and see where it leads. Well, I done saw this lovely this article here, and I haven't read it yet. And I thought I'd read it y'all to you as a science thing. The title says it's from this website called ScienceAlert.com. Something that was recommended to me in YouTube, not YouTube, but Google Chrome's news feed, kind of where they just give you discovered articles, and it says scientists grew stem cells, mini brains, then the brains sort of developed eyes. That's what it's about, eyes. Oh, excuse me, help me. Make sure I'm in the camera frame right here so y'all can see my ugly mug. But yeah, I'm gonna read this article to y'all and then give you my opinion on it. It says scientists grew stem cells, mini brains, then the brain sort of developed eyes. Many brains grown in a lab from stem cells have spontaneously developed rudimentary eye structure. Scientists report in a fascinating newspaper on tiny human-derived brains and organoids and grown in dishes. Two blatantly symmetrical optical cups were used where cups were seen to grow, mirroring the development of eye structures in human embryos. This incredible results will help us better understand the process of eye differentiations and develop as well as eye disease. Which to me, I have a brother who suffers from an eye condition, and I also suffer from a lazy eye, so I can see where that would be beneficial to the communities where people need to see. We all need to see. We all need eyes, and I think that's a wonderful. If we can move one step closer into curing some sort of eye disease, I say great. That's wonderful. That's just that part, and it says, our work highlights the remarkable ability of the brain organoids to generate primitive sensory structures that are light-sensitive and harbor a cell type similar to those found in the body, said the neuroscientist J. Gopalkrishna. I'll spell out his last name, Gopalakrishan of University Hospital of Dusseldorf, Germany, and Dusseldorf. If you know Willy Wonka and the Chocolate Factory, that's where I think Augustus Gloop was from. I think it was either Dusseldorf or Dusselheim. Augustus Gloop. The really, really big nincompoop. The one that got stuck up the tube. These organoids can help study brain-eye interactions during the embryo, develop model congenital we'll just call it genitals, rentital disorder that generates patient-specific retinal cell types for personalized drug testing and transplantation of therapies, whatever that word is. I spell it out for you, THERAPIES. Brain organoids are not true brains as you may think you might be thinking of them. They are small three-dimensional structures grown from induced purple punctate stems. The cells harvested from adult humans and reverse engineered into stem cells that have the potential to grow into many different types of tissue. In this case, these stem cells are coaxed to grow into blobs of brain tissue, without anything resembling thoughts, emotions, or conclusionists. Such mini brains are used for research purposes when using actual living brains would be impossible, or at the very least an ethical tricky testing drug. Response, for example, of observing cells developed under certain adverse conditions. This time, Gorlapashan and his colleagues were seeking to observe eye development. In previous research, other scientists have used embryonic stem cells to grow optic cups and structures that develop from almost the entire globe of the eye. During the embryonic development, and other research have developed optical cup-like structures from induced purpotent stem cells. Rather than grow these structures directly, Glen's team wanted to see if they could grow as integrated part of a brain organoids. This would add benefits of seeing how the two types of tissue can grow together rather than just growing optical structures in isolation. Eye development is complex process, and understanding it could allow underpinning the molecular basis of early retina disease, and research wrote in the paper. Thus, this critical study of optical fasciculi that are promortem of the eye, whose prosem end is attached to the forebrain, essentials for proper eye formation. Previous work in development of organoids show evidence of retinal cells, but these did not develop in optic structure, so the team changed their protocols. They didn't attempt to force the development of pure neural cells at the early stage of neural differentiations, and added retinal accentate to the culture medium as an aid to eye development. There are carefully tended baby brains formed optic cups as early as 30 days into development, with structures visible at 50 days. This consistent with the timing of eye development in human embryo, which means these organoids could be useful for studying the interaction of this process. These are implications too. The optical cup contains different retinal cell types which organized into neutral networks that respond to light, and even contains lenses and corneal tissue. My brother, who has an eyesight condition, he had cornea transplants and stuff. That's what he had done at the Kellogg Eye Center in my state of Michigan, down in Ann Arbor. Finally, structures deployed retinal connectivity to regions of brain tissue. In the mammalian brain, nerves, fibers of retinal ganglion cells reach out to connect with their brain targets, an aspect that has never before been shown in virtual system gameplay, and reproducible of the 314 brain cell organized. The team grew 73%, developed optical cups. The team hopes to develop strategies for keeping these structures visible longer time scale, performing more in-depth research with potential of the huge, researcher said. Optical vesicles containing brain organized displaying highly specialized neural cell types can be developed, paving the way to generate personalized organoids and rental pigments of epithelial sheets. Spell that out for you. EPITHELIAL sheets for transplantations, they wrote their paper. We believe that these are the next generation of organoids helping to model retinal plasticity that emerged from early neurodevelopmental disorders. Researchers have been pulsing cells. So from what I'm reading of this article here, I caught my eye. I'll put a link in the description to this so you can read it. I don't know how to do the whole on videos, how to do the whole post this article and like they do, when people do reaction videos. I don't know how to do that fancy video stuff. That's why you're seeing my ugly mug, the whole time I'm reading this. But anyways, basically what's my thoughts on this? I think it's great, I think it's great that somebody out there is messing around trying to develop ways to cure certain eye diseases. Look like it's going to be towards retina stuff, Scientists grew stem cells, mini brains, and then the brain sort of developed eyes, and they're fiddling, and it looks like their goal is to cure some eye stuff, like eye troubles. I personally, as you can tell right in this video you're seeing right now, I have a lazy eye. Always have. Had it ever since I was a kid, and so therefore I used to wear glasses, I had an eye that looked like it was in outer space, And I always took it out of fun. When I was a kid, I remember with my lazy eye trouble wearing an eye patch over the good eye. Because what they would do is they would have you wear an eye patch and you would make your eye focus and stuff, And you do this, you cover up your good eye and make it focus. That's what you did. You covered up your good eye to make your lazy eye, the muscles and whatever in your lazy eye to work. And that's one thing too. And then plus on top of that, I was always hard of hearing and always talk funny. Which, that's what made me want to do comedy, is because, in a lot of ways, is because I have a lazy eye. I talk funny from being hard of hearing. So I thought it would make a good combination, to be that funny guy that makes men and women laugh and say, ha ha ha, And when I think about this, I think it's great, If we can cure one eye condition, then that will help lead us to cure more and stuff, I know with lazy eye, like my eye condition, lazy eyes, you can go and have a surgery done to correct it, but I can still see out of that eye. So I'm afraid of going in for the surgery stuff like they can do. I'd be afraid of them ruining the eye where I couldn't see out of it, where I'd be blind in one eye. I can still see out of that eye good, so I figure it works pretty good. Why mess with it? And when I was a kid, I would just have to wear an eye patch for so many hours in the day. I'd wear the black medical piratey media style accent, and kids would always make fun of me because that was when I was in middle school, and I was in elementary school, actually it was. Kindergarten, I remember, back in the 90s. Back when dirt was new, but yeah, basically my opinion is I think it's great. I think we should do more. I think they should continue with the research. If we can cure one eyesight trouble, that will lead to cure more and more, The only thing is I do believe this, when you cure one disease, you discover a new disease, and so, Yeah, sometimes you can't win them all, but hey, somewhere out there, there's probably somebody seen the exact same article and they're like, that has the condition where this would come in handy, and they might say, man, that'd be great if I could see, because we forget how important our eyesight and abilities to hear, see is, I'm one of those people, I'm hard of hearing, and so I'm always, what you say? I'm doing that old people, what you say? Speak up, you son of a bitch, I can't hear you, Oh, and stuff, like old people and stuff, but yeah, basically my understanding, I think it's great what this doing. I guess the guy who published or authored the article there was called Michelle Michelle Star. Michelle Star. It was posted August 17, 2021. Something that Google recommended to me, but yeah, basically I think it's great. I would love to see them use this, what they're talking about, to try to lead to curing an eye disease, and it'd be great. Well, that's it for now. This is a pretty long video. I don't want to keep rambling on and on, because who wants to watch an hour-long video? This is only 16 minutes, but still. But if you like what you see, like, subscribe, favorite. Like every other YouTuber, like, subscribe, favorite, follow me on everything, stalk me. I shouldn't say follow me, I should say stalk me on everything, because, well, I'm a fucking weirdo, so, yeah. Just trying out different things, seeing what the fuck works. But, yeah, subscribe to this channel if you want to see more. Help me become that well-to-do guy, that popular what the fuck, and say, hey, you're that guy,